Alright, so 5.6 is all about inverse trig function. I'll show you how a couple of them are come by and then show you how to use some of them as well. So the basic idea, if you wanted to prove one of the trig functions, I mean, you could just look them up in the table if you didn't know what the derivative of arcsine was. But you really want to kind of change the function of arcsine to sine. So if you took the sine of both sides, you get the sine of y equals x, which then puts me in the mind of right triangle trig, SOHCAHTOA stuff. So in this formula, it's always kind of an angle. So this would be our y equals our opposite, which is x over hypotenuse, which is 1. So if I put it that way. Now if I wanted to complete the triangle, I could use the Pythagorean theorem. So we have a squared plus x squared equals c squared, 1 squared. So a would be 1 minus x squared, or a squared would be that. And we have the square root of it. I'm not going to put plus or minus on there because we're talking about sides of our triangles. 1 minus the x squared. Okay. So the idea now is, what we want to do is figure out, we've got our picture, and we're going to implicitly differentiate as well. So from here, let's start taking the derivative of both sides. So we cosine of y times y prime, the derivative of the inside, chain rule, equals, well, just 1. Okay, so y prime is going to be equal to 1 over the cosine of y. Okay, well, what in the world is cosine of y? Well, now I got to look back at my picture. So cosine is adjacent over hypotenuse. So what we have is a 1 divided by, well, the square root of 1 minus x squared. And that's really it. So the derivative of arcsine is just going to be 1 divided by the square root of 1 minus x squared. So at first it seems almost impossible to kind of work with this, but if you change this to sine, that tells you what picture to draw. Fill out your picture. And then we also take the derivative of both sides and we can solve for our y prime, which was what sine equals. Cosine is going to be basically the exact same thing, except now you're going to put the x and this root on the other sides. So you should do the cosine on your own. And let's do tangent as well, just to practice it. Alright, so we're first off going to make our sine of y, or sorry, tangent of y. We'll take tangent of both sides, so tangent of y equals to x. The tangent of arctangent, they're inverses, they cancel out. And then from here, we're going to, well, you can take the derivative of both sides if you'd like to right now. So it's secant squared y times y prime equals 1. So y prime is going to be our, well, 1 over secant squared, or cosine squared y. Okay, so that's what y prime is equal to. But before we can tell what this is, we have to draw our picture. So I draw our picture. It's got to be a right triangle. And we have y is our angle. Tangent is x over 1. Opposite over adjacent. And then if we did our Pythagorean theorem, it would give us a square root of 1 squared plus x squared. And 1 squared is just 1. Okay, so cosine is, well, it's adjacent over hypotenuse. So we end up with, and it's squared, you get 1 over the square root squared, 1 plus x squared. Alrighty. So that's really kind of what we have for our arctangent. Now you can do the exact same thing with our secant, our cosecant, but at some point you're probably going to just look them up and fill them out. So you should look up the next few and fill out the rest of your note sheet. Once you have them, we're going to just try to apply the rules. Now don't forget, these are just x's. If this was a u, this would be u, and then you would need a du here. So don't forget your chain rule on these. So let's see if we can't try one. Alright, so we've got someone dropping water balloons on somebody else, and we have them from a height of 50 feet, so 50 feet off the ground, and someone's standing 50 feet away. So nice 45, 45, 90. And we have to figure out how fast is this angle that you're watching them changing at 1 second or at 15 seconds. Well, just so you know, 50 feet, you're going to hit the ground before 15 seconds. So that's a little bit of a trip. So if it's on the ground, the angle of change is going to be nothing. Now, a couple things to even note before we start the problem is whether the change in theta over time should be positive or negative. Well, you're going to be starting, it's going to be falling, so you're going to be following it downwards. It's going to get smaller, so I expect this to be negative, not positive number. All right, what else have we done? Well, we have a y, we have an x, and I have no clue about the hypotenuse, so I'm probably going to be going with tangent. So tangent of theta is my y. Now, I don't want to let it be 50, because it's 50 right in the beginning, and then it's going to be, well, 49 pretty quickly, 48. It's going to drop. So how fast is it dropping? What's the position? That's the height. Well, acceleration is negative 32, because we're talking about feet. I don't want to use the negative 9.8 because we got feet. Our velocity is going to be the antiderivative, so negative 32t plus the initial, and our initial is 0 because you're dropping them. So 0 for my initial velocity. And my displacement is the antiderivative of this, so negative 16t squared plus the initial height plus our c value. That's where the 50 comes into play. And we can see that our distance, our height, is changing. It's starting at 50 if t was 0. And as t gets larger, you're going to have a negative number plus a positive. It's going to get smaller and smaller and smaller. This is really what we want to have for our y value. All right, so tangent of theta is going to be negative 16t squared plus 50 over, now our x doesn't change. This thing's just falling. It's over just 50. And you can break it up as two separate ones. But basically what you have is tangent of theta, is going to be the arctangent of negative 16t squared, and it's probably easier to put them each over 50, plus 1. And now we want to use our arctangent formula. Now remember, it's du. Normally it's a 1, but you got to put your chain rule. So it's whatever it is, x squared. So this is our x. So negative 16t squared over 50 plus 1 squared plus 1. Remember, it's plus 1, not minus 1. And then normally it's 1 on top, but it's got to be du on top. So it's going to be negative, well, I didn't reduce this to begin with, so I'll just keep it unreduced. 32t over 50 on the top. So this is going to give us our d theta, dt, because we took everything in terms of t. And now if I want to tell what it is at 1 second, we're going to take this equation and we're going to plug in 1 for t. If we want to find out what happens at 15 seconds, well, you got to be careful because it's already hit the ground. But generally speaking, you would probably plug in 15. So that 15 is a trick question, and it's just 0. So take your calculator out and figure out what that is at 1, and that's really it. Now, before I move on here, there's another way of doing this problem, and you may just consider it to be easier. So the other way of doing this problem, so this is the way that they're looking at, making an arctangent and then taking the derivative using the arctangent formula. You can take the derivative of both sides right here. So let me give it a little bit of space here. Well, you can rewind this if you need to see this, but I'm going to get rid of it so that I have some space. So the derivative of tangent is secant squared d theta. And on the right, it's going to be negative 32t over 50 plus, well, derivative of 1 is just 1. Okay, well, I want to know what d theta is. Well, technically d theta dt. And so all I got to do is multiply both sides by my, well, not secant, but my sine, or cosine, sorry. So d theta dt equals negative 32t over 50 times cosine squared theta. Now the question is, what in the world is cosine squared theta? This is 1 over cosine, multiply both sides by cosine squared. Well, this is where you can figure out what the actual values are. You can find theta if you wanted to. If you plug in 1, you can get a height. It's going to be, well, 1 squared is 1, so 50 minus 16 is 36. I could do arctangent and get theta, and then plug that in. So at that point, you actually have a value of theta. We didn't need this for the other way, but in this case, I can do it directly, and then I don't have to do the arctan formula. So either way will work, but go through and get used to the arcsines, arctangent, arcsecants, because they all are a little bit trickier. They're bigger formulas than most of the other ones. So write them down, find them in the book, find them in the front of the book, whatever you need to, and then practice them, because it's going to take you a while to understand what they are and how to use them.